Answering another subscriber question, this time from Shannon. Let's take a look. And this is in response to the ASRock WRX80 rack mount with Thunderbolt motherboard, which is pretty exciting because, to reiterate, that's going to be an ATX form factor. Okay, Shannon. Now let me give you some background before I read this. Shannon's been one of our faithful subscribers now, going on probably about a year. And as my best recollection of going back through the messages, he's built a TRX40, and we've talked a lot about the WRX80. So some of the stuff that Shannon's talking about that I'm going to share with you in this message is we need to look at technology for a point in time. I'll get to the title of this video in a second because I'll read the message, then I'll give it to you. We're going to look at the Z690 chipset, and we're going to look at a specific motherboard. But I want to address it the way Shannon's looking at it. Then in another video, we're going to look at another Z690 chipset. And I'll say, for those that want the short answer, don't. Let's take a look. And if you ask what I mean by that, we'll get into it. Okay, Shannon Bailey. I was considering building a 4K video editing PC. Number 1 priority. Primarily for Premiere Pro. Number 2 priority. So I was considering a new Intel build with the new Intel i9 12900K CPU with 8 P cores and 8 E cores. We'll get into that in a minute too. And I was considering the ASUS ProArt Z690 Creator Wi-Fi motherboard. So that'll be the title of our video. With 64 gigs of Kingston, and at that speed, that's going to be on that motherboard DDR5. And for 4K video editing, I would like to see what the RTX A2000 with 3,328 CUDA cores with 6 gigs of video RAM and ECC will do. Okay, based on that specs, first of all, the bottom part, the RTX A2000, I think you're going to need to bump that up. Separate video we'll get to, because there's a lot of stuff I want to get into with this. And some things that Max and I have been talking about that I have not focused on that I need to get more into, especially since Shannon is looking at building on this particular platform. So what we're going to do is we're going to look at the motherboard. We're going to look at the Adobe After Effects multi-frame rendering CPU optimization formula. And we need to also look at the CPU that Intel's doing, which, you know, they finally got, if you want to call it 16 cores, you know, great. I still wouldn't do it, but I'll get to it and I'll explain why. We're going to look at the RAM, and of the 3 things that PCI Express 5 is going to give us, it's going to give us the least important first, then the second, and then the most important last. And the most important, which I think is significant, that we're going to talk about in the next video on another Z690 ASUS motherboard, but I'll save that. So as we look at what he wants to do, let's first of all look at the formula. The Adobe After Effects multi-frame rendering CPU optimization formula. And what that allows for are 3 elements. And keep in mind all this that's about rendering, because that's what we're looking at on a specific motherboard. Rendering is all about that formula for that application, for that group of applications, which state CPU cores, amount of RAM, and the amount of GPU video RAM. Okay, the CPU cores are 16 cores, so 16 cores times 4 would be 64 gigs of RAM, which is what he wants to do. Okay, that's a good match. But I think we can do better, because there's another aspect of that that we're not talking about that Max has mentioned that I need to go into. But I will save that for just a minute, so hold that thought. Okay, based on the 3 things that PCI Express 5 should deliver us, we're going to get aspects of only 2 of those things. The third thing that's the most important is not on this motherboard. And as far as the RTX A2000 with 8 gigs of video RAM, based on 16 cores, he needs a GPU that's got 16 gigs of video RAM. Okay, we've addressed the formula. Now let's go look at the motherboard, because there's 3 things I want to look at on that motherboard. The first thing we're going to do is go to ASUS's website for the ProArt Z690 Creator Wi-Fi. We're at Overview. Let's go to the tech specs. 2 items in particular we're going to look at, but we're going to eventually go to the manual for those 3 things we're looking for. We're looking for expansion slots and storage, and we're looking for congruence. In other words, we want to look at the information, we want to read it, and we want to verify as we extrapolate. The first thing we're looking at, we have 2 PCI Express 5, 4, or 3 slots. Okay, PCI Express by 16 mechanically, 1 slot by 16 electrically, or 2 slots each by 8 electrically. And then we have, through the chipset, 1 PCI Express 3.0 by 16 slot, mechanically, electrically by 4. And we'll get into the issue of bifurcation and RAID, because there's some details that aren't here that we need to address. I got to say, what you guys put up with on Intel is just, man, pretty wild stuff as you walk that line. But even walking that line, Intel has finally decided to open that up a little bit on the Z690, and I'll show you that information when we get to it. We've got a lot of stuff here to cover, and I'm going to try to do the best I can to keep this tight, because what I'm going to eventually do is I'm going to show you a chart that's going to have 4 CPUs on it. One for the Z690, and then I want to show you and throw 3 at you that are from AMD that we'll get to in a minute, because there's a lot of information that as we go forward in time, as the technology moves, there's other things coming down the pike that right now I'll say for the Z690, this is something to look at, but this is not something we want to do, whether it's DDR4 or DDR5. So let's go back to the specs. And we can scroll on down to storage. Okay, we have 4 M.2 connectors and 8 SATA ports. And M.2_1 is to the CPU, and it'll be PCI Express 4.0 mode. Now keep that in mind. You're going to be able to do M.2_1 at PCI Express 4.0. And let's go back up here and look at this again. The processor is going to give us a PCI Express slot by 16 electrically, a single slot, or if we use both slots, they are by 8. And it says those slots are PCI Express 5. Okay, PCI Express 5 on the PCI Express slots, but PCI Express 4 on the M.2. And that's the major point I want to make. Now on the chipset, we got M.2_2, 3, and 4 all through the chipset, and all 3 of them are PCI Express 4. And M.2_4 shares with either PCI Express 4.0, M.2, or SATA M.2, but it also shares bandwidth with plain old SATA. So you have to decide as you look at the 3 stars if M.2_4 is going to be an M.2 NVMe, or if it's going to be SATA 5 through 8. So 5, 6, 7, 8. And doing the math for 4 SATA ports, would you rather have 4 SATA drives or 1 M.2 drive? I'd rather have the 1 M.2 drive. Let's go back. Now let's go over to support, and let's see how many manuals they're going to have for us. We've seen as many as 5. They always show the FAQ first. I don't know why, because there's nothing there. Hardly ever is. We have a user's manual. We have a quick start guide. Sometimes there's a RAID manual. That's what I'm looking for. No. Okay, so the user's manual and a quick start guide. Quick start guide is not helpful. The user's manual will be. Okay, I've taken the liberty of downloading the manual, and the first thing we're going to look for, I'm going to do a search for layout. I'm hoping there's going to be a diagram in here. So motherboard layout, and we're going to have specifications we're going to look at. Oh, this is going to be a jewel. That's a choice. Connectors with shared bandwidth. We'll get to that. First thing I want to do is see motherboard layout. I like to look at what, where, why, and how. Okay, PCI Express by 16_1, PCI Express by 16_2, and PCI Express by 16_3. Okay, _1 single slot, 16 lanes, PCI Express 5.0. _2, if these 2 slots are used together simultaneously, they both then will be by 8 electrically, but they'll still be PCI Express 5. Okay, if we, this brings into the point of bifurcation. I'll come back to that in just a minute. And then, of course, PCI Express by 16_3 mechanically is by 4 electrically. So 3 16-lane slots to reiterate mechanically, but electrically depends. M.2_1, M.2_2, M.2_3, and M.2_4. Okay. As it relates to resources, we're going to look at this slot, PCI Express by 16_1, and we're going to look at this one, M.2 connector. And what we've already learned that we're going to verify, because we want to see a congruence of information. In other words, you know, I see this here, I want to see it there, and I want to see it there. Once I have verified this information for clarity, then I want to go through this, because before I've told you guys things that you can't do, but then later I had to do another video to tell you why yes you can, but why you shouldn't. So I'm going to go ahead and try to get all that in here to understand and explain the what, why, and how. So the first thing we're going to do is dissect how that first resource works. Let's go look at the CPU and see what it's got, and then we're going to look at the chipset, and then we'll come back to the motherboard. You'll see, stay with me. So now we're going to take a look at the CPU, and all these links I'm sharing with you will be in the description, so you can check this stuff out and take a look for yourself. Okay, the 12900K CPU, we have 16 cores, 8 performance cores, 8 efficiency cores. I'll put a link up, you can read about that. Don't want to get into that right now because that's a diversion. Let's stay focused. Can support up to 128 gigs of memory. Okay, that's the first thing we need to know about. Memory type can do DDR4 or DDR5, and the DDR5 is 4800 and the DDR4 is 3200. So that confirms what Shannon wants to use. Okay, here's something that I haven't been talking about that I need to because Max has mentioned. He's absolutely right. Maximum number of memory channels. The number of memory channels refers to the bandwidth operation for real-world applications. Yeah, right. That's not quite all the information. Anyway, there's 2 channels. So my guess is this motherboard with 2 channels is probably going to have 4 memory slots, and you'll have 2 sticks on one channel, 2 sticks on the other channel. So you get your dual channel. Interesting. So I will ask you now, would you rather have dual channel memory, would you rather have 4 channel memory, or would you rather have 8 channel memory? I'm just saying. That's one little thing that's, keep that in mind, state of play, let's go back. Because this is all about what Shannon's trying to build. He's already built a TRX 40, so he has 4 channel memory. He's looking now to build a machine that's going to give him one thing, and that one thing is DDR5 4800. Again, the Adobe After Effects multi-frame rendering CPU optimization formula speaks to 3 things. It's about CPU cores. It's about quantity of RAM. Doesn't speak to dual channel, 4 channel, or 8 channel. It's just about quantity of RAM. The third thing it speaks to is the video RAM. So CPU cores equals video RAM. Okay, right now we are looking at a faster RAM that's not available, and I'll have a link up to an article that says why. It's about the chips that control how all that works. It's an integrated chip. I'll share the link with you in a minute. Okay, let's scroll on down and see what else we've got. And there's 2 different SKUs on the CPU, 2 different models, but the model he's speccing is the only one that's available. The reason I say that, it's got video on board. It's there, whether you use it or not. And if you bought the CPU that doesn't have it, that's not available yet, you'd still have only 16 cores. So you pay a bit of a premium for it. What I'm looking for, okay, OpenCL support. Okay, the DMI interface is version 4, and that is 8 DMI lanes. Okay, right here's what I'm looking for. Okay, the CPU supports PCI Express 5 and PCI Express 4, and the configuration can be 1 16 plus a 4 and 2 8s plus a 4, which is what we verified that's in the BIOS. And it says here we have 20 PCI lanes. Okay, my point, I hope you understand where I'm going with. Okay, if the CPU has 20 PCI lanes, and I'm using a GPU that's in a 16-lane slot, and I put an M.2 drive in that slot above it, like we'll look at on the motherboard, that gives me 4 lanes, then how come I can put a GPU in here, which is not available yet? We're talking about the RTX 4000, another conversation, different video. But anyway, it's coming. But the one thing that is the most beneficial would be able to put a PCI Express 5.0 M.2 NVMe drive in here. I cannot. According to the specs, I'm going to get PCI Express 5.0 on that 116-lane slot, and I'm going to get PCI Express 4.0 on that M.2 connector. Okay, that's confusing to me. If I've got 20 lanes, I should have 16 and 4, and they should all be the same, but they're not. So the first thing I get is faster RAM that's not available, that really doesn't say anything about the formula for rendering. The second thing I can get, which is pretty cool, is that I'll get a PCI Express 5.0 16-lane slot for a GPU that's coming out next year. I'm looking forward to. And the third most important thing that I'm interested in is the M.2 drive that this motherboard is not going to support. Now that's a real bummer, because I want you to keep that thought and hold that thought, because in the next video we're going to take a look at a motherboard that has an M.2 add-in card that will support one M.2 NVMe PCI Express 5.0 drive. And oh, by the way, it's a dual adapter, can't be bought separately, only with the motherboard, not available yet. But according to the specs and the way it's listed, it will support 2 PCI Express 4.0 drives, or it will support 1 PCI Express 5.0 drive. Man, this stuff's nuts. The Z690 is a piece of work that a lot of people are getting worked up over for no reason at all. Let's go back to the specs. I got some more I want to share with you that I hope will help you understand as we extrapolate this, because we want you to understand our goal is to keep it simple, make it work, and look at what you're getting. Not what the marketing says, but look at what you're getting. Let's go back. So what else do we get on the CPU? Okay, so we're looking at PCI Express 5 and PCI Express 4. And we have a by 16, which we verified, but we've also seen that that by 16 is 5.0, but that by 4 is 4.0. It doesn't point that out, but I am. Let's go look at the chipset now and see what that delivers. because again, you got to remember, a motherboard is the foundation of the computer, but the chipset is the foundation of the motherboard. The chipset's rule. So let's see what we've got with this. So this chipset is going to give us 2 DIMMs per channel. That verifies that. Goes back to indicates the quantity of dual inline memory modules supported by each processor memory channel. So dual channel, yeah. The DMI interface, 8 lanes, and the chipset supports PCI Express 3.0 and PCI Express 4.0. Well, isn't that special? And the PCI Express configuration is by 1, by 2, and by 4. By 1 is usually a slot or a SATA port. By 2 is usually a slot. And by 4 could be an M.2 connector, or it could be a slot. And there's 28 PCI lanes there. Okay, so let's go back now and let's take a look at the motherboard. Oh, and while we're at it, we need to look here at the RAID configuration because we're going to eventually get to this. The RAID configuration, somebody missed a comma. That should say 0, 1, 5, and 1, 0. And PCI Express or SATA. And yes, you can have both on the motherboard, but the 2 of them can't be combined together. Both of them can be there, but it has to be M.2. Well, now that I brought it up, I got to finish that. It either has to be an M.2 RAID or it has to be a SATA RAID. And if it's an SSD RAID, it can be an M.2 NVMe RAID, or it can be an M.2 SATA RAID, or it can be an SSD RAID. But each one of those 3 that I've just outlined, SATA, SSD, and M.2 NVMe are separate. They can both exist in a computer and at the same time, but separately. So you have this RAID and that RAID. I get called on that every once in a while, so when I skip over something, it's, let's keep it tight and keep rolling. And it's got integrated Wi-Fi, and the PCI Express configurations are 1x16 plus 1x4, which we verified, or 2x8 plus 1x4, which we verified. Okay, so 28 lanes, dual channel memory. That's really exciting. So looking at the motherboard, and there's our 4 memory slots. So DDR5, DIMM A1 and B1, and then A2 and B2, so that you get your dual channel. So I'm looking at, excuse me, not me, but Shannon. Let's go back to his message. Shannon is looking at building a brand new computer with an i9 12900K CPU that'll have 8 performance cores and 8 efficiency cores. So his 16 cores, and he's looking at the ASUS ProArt Z690 with 64 gigs, 4800 RAM. Yeah, Shannon, I got to ask, why? Doesn't make any sense. You got a brand new motherboard, which is great, which gives you DDR5. What do you gain with DDR5? You don't have the GPU yet to take advantage of PCI Express 5. And then the third thing, to reiterate, is the M.2 NVMe drive for PCI Express 5 that is nowhere on this board. This board will not support it. So my first question is, why would you choose this particular board? Is it because it's the ProArt? Okay, I understand that, but there's not enough there. And yes, Thunderbolt 4 is also there, which is pretty cool. But as we go forward with Thunderbolt 4, it's going to be on any Z690. So there's other motherboards we can look at. And the other motherboard may be of better interest, but it's kind of pricey based on the technology. But if you're after the technology, I would say, folks, wait and leap over this. So anybody right now that's thinking about buying a Z690, don't. I got to tell you, don't. Because it's just, whether you get a Z690 that's DDR4 or DDR5, I got to put that out there because someone's going to come back and say, well, what about DDR4? If you're going to do DDR4, I would do DDR4 with at least 4 channel. But based on what's going on with the processors, with the chipsets, I would suggest at least 4 channel, preferably maybe 8 channel, because we need to do some zooming in and zooming out as we're looking at this. And the motherboard I wanted to show you guys that I'm going to show in the next video, when I saw this message from Shannon, I just thought, oh, Shannon, we got to do better. So knowledge is what we're all about. We're here to share. So I hope this helps, but I am by no means finished. We are just getting started. So I got some more stuff I want to show you. Okay, we know the motherboard layout, which we may have to come back to. Now we need to go take a look at the specification summary. This is on page 7. And as we zoom in on this, again, we're looking for expansion slots because we want verification of the information as well as storage. So we have on the processor 2 PCI Express 5.0 slots by 16, and a single slot by 16 mechanically and electrically, or in a dual configuration, both are by 8 electrically. Then through the chipset, we have 1 PCI Express 3.0 slot by 16 mechanically, and electrically it's a 4-lane slot. And we'll get into the bifurcation here in just a minute, because that's going to get really interesting. When you think about, if I have a 16-lane slot and if I've got video on board, well, we'll get to that. And of course down here the 4 M.2 NVMe connectors, M.2_1 to the CPU, which will be PCI Express 4, yet to the CPU you'll have that 16-lane slot, PCI Express 5. Yeah, hold that thought. We got to look at bifurcation. And then M.2_2, 3, and 4 through the chipset, right? And they are all PCI Express 4. That brings up the issue not only of bifurcation for RAID. Let's now go take a look at the connectors with shared bandwidth. And this is on page 12. This one is most enlightening. I think you'll get a kick out of this. All right. PCI Express with 16_1. And I'll make that a little bit bigger so we can get a good picture of that. Yeah, okay. PCI Express with 16_1, 1 slot, PCI Express 5.0 by 16 electrically. And in the second slot and the primary slot, if you use PCI Express by 16_2, those 2 slots, to reiterate, are PCI Express 5.0, but they are by 8. So you have to ask yourself, if I have video on board, can I bifurcate that to get 4x4x4x4? Well, that's a good question. Hold that thought. And if we look at the configuration for PCI Express by 16_3, that 1 slot by 16 mechanically, by 4 electrically, and it's PCI Express 3. And then your M.2 connectors, M.2_1, M.2_2, and M.2_3. All 3 of those are PCI Express 4.0 by 4. Perfect. If you were to RAID, I would suggest those 3 could be in a RAID. And of course, most everybody asks about RAID 0. That's what we've done the most, which is what I call the RAID flying by the seat of your pants. Of the 3 types of RAID, and I've now found out there's a 4th type of RAID that we're going to do also in another video. Max knows about it. I would not RAID the first drive, but I would RAID these other 3 because they're through the chipset. And how speed has gone typically, because on this system that we've been advocating, which is the Gigabyte TRX40 Designaire, let me show you. Where we have dedicated resources of 2 16-lane slots and 2 8-lane slots, and we have 4 M.2 connectors on the motherboard, 2 that are to the CPU, and then we have 2 more underneath 1 heatsink that are through the chipset. Okay, the fastest are the 2 to the CPU. The second fastest are the ones in the slots, and then the third will be the one through the chipset. So as it relates to this, even though you're going to have 4 M.2 NVMe connectors, and all 4 of them will be PCI Express 4, I would not RAID all 4. You can, but I would not. I would, to reiterate, keep that primary drive as a separate, and then RAID those other 2 or 3, if you choose, for a scratch drive. Because to set up a RAID like a RAID 0, you need at least 2 or more drives. So you could do those 3 on the chipset. They'll be a little bit slower, but if they're in RAID, they're going to be pretty fast. And remember, because of the shared resources, you're going to lose some SATA ports. But if you put the M.2 drive in there, you won't forget about it, because if you plug a SATA port in there, it ain't going to work, which is 5, 6, 7, and 8. So you'll still have 4 SATA ports, which probably will be plenty. Let's go look at bifurcation. The nice thing about this, we can do a search on the actual word bifurcation now, because ASUS has decided to embrace that term, which sure simplifies life. So again, it says check, and I just did a search in the manual for the word bifurcation, and it says check the PCI Express bifurcation table in the support site. Okay, if I do a search in this document, which is the manual, for that word, it's not found anywhere else in that manual. It's only in that one place. What they don't tell you, that I'm telling you, we're going to have to go get that information. It's on ASUS's website. Don't sweat it. I'm going to have a link up, and it's what I call the ASUS bifurcation, motherboard bifurcation table, but we'll get to it. So what we need to remember is our chipset and the motherboard. This is the Z690 Creator. Now this is the motherboard bifurcation table on ASUS's website. It's an FAQ, and we're going to do a search first for the Z690, and we're going to find several boards. And as we look right here, I want to get the syntax right. So that's the ProArt Z690 Creator Wi-Fi. Now I'll do a search on that document with that syntax, and let's look at the chart, and I'll try to keep this as large as I can, but yet still small enough so we can read everything. Okay, the ProArt Z690 Creator Wi-Fi, and this shows us PCI Express bus 16_1, it says 2 and there's 2 stars, /0, and then PCI Express bus 16_2, 0/2 and 2 stars. So let's see if we can figure out what those 2 stars mean. Please insert the M.2 SSD cards in the Hyper M.2 bus 16 card, socket 1 and 3. You get that? Right there, socket 1 and 3. Because the question comes up, can I put a dual M.2 NVMe adapter in here? That's a good question. Can I put a quad adapter in here that would take 4 drives? Well, this is really strange. You're only going to be able to see 2 drives, but you have to use a quad adapter to see those 2 drives because of that. In other words, if you put a dual adapter in that saw 1 and 2, because we talked about this, the sequential numbering of drives, and this is before you even get into the enumeration of stuff. But as that's identified on the card, with a dual adapter it's 1 and 2. Whereas when you're on a quad adapter, it's 1, 2, 3, and 4. Okay, sequential. If you were to put a dual adapter in, you would only see 1 drive. If you put a quad adapter in, you're only going to see 2 drives because of the way this is configured, which is nuts. So let's look again. PCI Express bus 16_1, 2 drives. If it's in PCI Express bus 16_2, it's 2 drives. Okay, the 2 drives and the 2 drives, this says in socket 1 and 3. Now if that's the case, we're going to scroll back up here and we're going to look at a picture that's going to give an indication. So from the top down, and this is going to get very specific. Okay, right here's some fine print. For the Z590, Z490, Z390, and Z370, install RST to use the RAID. And on that, on those chipsets specifically, only Intel SSDs can activate the Intel RAID. The Z690 does not have that issue. So for clarity, you can use anybody's M.2 NVMe drives you want, which, you know, I don't understand Intel's thinking on that. So I'm glad they finally freed that up, but we needed that clarification. So this is a big step for Intel on the Z690 to open that up. Let's go back. I hope you guys find value in this and understand putting all this together why we think it's so important to share with you, to look at the technology. But hang on a second, hold your horses. Okay, and we were quite familiar with the X299 and what was required with the VROC. And that platform looks like it's going to be updated because it was getting long in the tooth, but that's another video. Okay, the next thing I need to show you about this issue with the chipset is to go back to what we were working on with how many drives go on the actual card, because this only works with a quad adapter. If you have, there's a good example, configurations, maximum M.2 SSD support, and that should say M.2 NVMe SSDs for clarity, will vary depending on different CPUs and motherboards. Follow the instructions to install. So when you guys ask me a question, I have to look because every one of them is different. Even stuff on the chipsets, I like to look at a motherboard. I like to know the brand, the model, and a lot of times the revision, so I can figure out what you guys are asking. I don't mind doing it, but I need that information, those 3 pieces. Let's go back. Because as you can see, for clarity, details matter. Okay, 1 M.2, it goes in M.2_1. 2 M.2, hold with me, bear with me, it goes in _1 and _2. All right. And if you have 3, _1, _2, and _3 consecutively. Now, 4 consecutively. My point, follow the steps below to install your M.2 NVMe SSDs if the PCI slot of your motherboard can read only 3 M.2 SSDs. So if we look again at the ProArt Z690 Creator, we can put 2 drives on there. If it's in the PCI Express bus 16_1, the bifurcation in the PCI Express bus 16 slot would be 2 and then nothing, or nothing and 2. So it looks like, according to this double star, in socket 1 and 3. Now I'd like to show you what you'd be looking at in the BIOS, but I cannot because it does not give any of that information about that feature in the BIOS. What you're looking at on the slots with lane assignments by 4x4. But suffice to say, with the information we've got, to reiterate, you can bifurcate, but you're only going to be able to see 2 drives, and those 2 drives have to be 1 and 3 on a quad card. And if you put a quad card in, that would take normally 16 lanes because there's only 8 lanes there. That's the 2 drives. Not sequential, not 1 and 2, but to reiterate 1 and 3. So I hope that kind of helps. Let's go back. So my question to Shannon, why are you choosing the ASUS ProArt Z690 Creator Wi-Fi motherboard. I don't understand. You're going to have to expound on that for me. I just don't see what you gain with that. You're going to have dual channel, so you're going back to something that's about 10 years old. You've got a brand new chipset with a new CPU that's going to give you PCI Express 5.0. I'll tell you what, let's go to PC Part Picker and let me show you some more information there that's kind of enlightening. Okay, we're going to go to the PC Part Picker System Builder, and we're going to first choose a motherboard, and we're going to look according by chipset. And let's get over here to the Z690, of which we're going to find 70 compatible products. Then we're going to filter by ASUS, of which we will find 18 compatible products. Then we're going to do a search for ProArt, of which we will find 1. I'm going to add that to the list, and I'll go back for just a minute. If you notice the ProArt, ATX, 128 gigs of memory, 4 memory slots. Then we're going to pick a CPU. Where I'm going with this is I'm going to pick RAM. We got to go through the process. And we're going to do the core count according to cores by 16 cores. And the one we're looking at is the 12,900. It's got video on board because the other one that without video is not showing to be available. So 2 items you can get, the CPU and the motherboard. We can find the motherboard even though no prices are shown. I can show you a link where it's available for pre-order. And I'll have a link up because I think this kind of comes into play. The ASUS ProArt Z690 Creator Wi-Fi, a new motherboard coming soon, $480. Okay, let's go back to our system builder. Now let's choose some memory because we know PC Part Picker is pretty good with this. This is DDR5, so we didn't have to select anything. It's going to show us because it knows that's a DDR5 motherboard. Now, it doesn't have a way to select like Thunderbolt 4, but we know Thunderbolt 4 is on there, so that's in the back of the mind, but not really important for this video. What is important is what you're going to get. What do you gain beyond just the marketing hype, smoke, and mirrors? Let's take a look at the memory. Now, any one of these, and we'll select this according to by speed. Let's just go ahead and pick by brand. Over here on the left, Kingston. That'll simplify life. And we have these choices, none of which are available. So you're going to do dual channel, which means you'll probably be using a couple of 32 gig sticks. As far as issues of performance on how that addresses dual channel, like on the another processor I'm going to show you that has an issue. If you have 4 slots, you're better off using 2 slots because of the way the memory controller is configured. My point is that RAM's not available, the motherboard's not available, but the CPU is. And the motherboard that I'm going to show you in the next video also is not available. It's more expensive than this. But of the 3 things PCI Express 5 can deliver, which is number 1, the last thing we're going to get, an M.2 NVMe drive. Remember, that's going to be on the Ryzen, I believe it's the E26 controller that we're waiting to find out about. But that's next year. Let's go back. What we would get based on that memory, we would have to go out and do a search for it, which is what I did on the motherboard. And this will probably come back at Kingston. Now, this happens to be the DDR5 5200. Yeah, I want to take a look at B&H. B&H does not even have DDR5 listed yet. I thought they might. DDR4 3200. I'll have a link up to this, and I'll also put a link up to the memory as soon as some of it becomes available. If we were to click on buy, it shows us the kit 4800, 16 gig. It says where to buy, but it doesn't say that's a single module. Let's do 4800 32 gig. That says kit of 2. So that's 2 16 gig sticks. Okay, and you want to use 64 gigs, which I agree with, but based on what Kingston is saying and what's available, to get 64 gigs, you're going to have 4 16 gig sticks. And the chip they're missing, I'll show you a link to an article about what the shortage is. According to this article on Tom's Hardware, it's the PMIC chip, the Power Management Integrated Circuit chip, and that's the holdup. And according to things I've read, maybe in this article, that chip is 10 times the price of the same chip on DDR4 because of the speed, what's going on. And the lead time on trying to get those chips is like 35 weeks. And other things I've read said for DDR5 to be on par with DDR4 is going to be a while. So remember, PCI Express 5 should deliver 3 things. The first is the RAM, which I don't see the benefit of, which you can't get anyway. The second is the slot, which we won't be able to take advantage of until next year. The third one, the one that I'm most excited about, I'm going to show in a motherboard in the next video that will deal with an M.2 NVMe drive that's PCI Express 5.0. That's what I'm getting excited about, because that's a drive that'll be 15,000 megabytes per second, and that should be wicked. But I got another chart I want to show you, because as we zoom out on this and look at that, because we talked a little bit about this motherboard with this chipset and these resources, but I want to zoom out some and give you some food for thought as we look at not only, again, memory that is dual channel, quad channel, and 8 channel, but let's look at some other 16 core CPUs. We got some other options that I really think you need to consider. Now I'm going to have a link into PassMark where I've done a comparison for those of you that want to do this just for grins. This gives you an i9, which is the 12900K, a Ryzen 9 5950, or a Threadripper Pro. Now, absent from this list, we don't have a TRX 40, because there is no TRX 40 16 cores. Max has been talking about this. And let me give you another link so we can get a little bit more into this, and I'll come back to this. Now, this link into AMD, and you can look at the URL, that's why I've left that up, for the AMD Products Ryzen Threadripper. We have to actually scroll down to the bottom to get to the details that I want to show you below the motherboards. And there should be a delineation line where we go from the 2000 series to the 3000 series. And this gives you a chance to see, for example here, if you want 16 cores, a 1950 or a 2950, and this is all part of the same conversation, so just bear with me. Then you're looking at the X399, which is PCI Express 3. Okay, for PCI Express 4, let me show you this. There should be a line through here when we go to the 3000 series, the 3960, the 3970, and the 3990. Those are PCI Express 4, and those are Threadripper 3s. But the cores, 24, 32, and 64, we don't have a 16 core, and Max has mentioned this, and I keep referring to it because he and I have been going back and forth on this a lot. He's right. We don't have a 16 core high-end desktop. And yes, Intel is getting ready to refresh their high-end desktop line. That's next year, but AMD is coming out next year. Now what we're going to see, and I'll have another link up for you, is we're going to see the next class of AMD processors that are going to be, it looks like the 5000 series. Looks like the 4000 series is washed. And it looks like the 5000 series is going to be Threadripper Pro. And it looks like, I don't know, don't hold me to it, but one of those could be 16 cores, which means building a Threadripper Pro on a budget build could be much more of a reality. And because of the motherboard we looked at previously that I just mentioned from this comment that brings all this together, if we can build a Threadripper Pro on the WRX80 in an ATX case, whether it's rack mount or not, is pretty wicked stuff. But even if you have to put it in a bigger case, the fact that you can have 16 cores, so because we've had some of you that need low core count, but you need a GPU with a high video RAM count. And several of you I know are chomping at the bits for that. Let's go back to that chart I put up on PassMark. So not so much at the clock speed, the turbo speed. We're looking at 16 cores, 24 threads, 16 cores, 32 threads. That's pretty straight. 16 cores, 32 threads. Okay. When we look at resources, a 3955, a Threadripper Pro, the 5000 series processor, if it follows suit and is going to be on the Threadripper Pro, is going to have probably a 30% performance improvement over that existing CPU. I would rather see, and yes, you look at the price, $800 for that CPU versus $1,100 for that CPU. You know, we're all about value and bang for the buck. And yes, I lean toward AMD because I think it's, you know, the underdog that's been valued. As I've said before, got to say it again, if AMD ever figures out marketing, it'd be wicked. But until they do, it's up to people like us. And that's what I want to extrapolate and pull this information out. So if you decide you're going to build on the Z690, other 3 things that you should get, what are you getting? Smoke and mirrors. Does it come with a feather or bar of soap? Forgive me for saying that, but I had to. Let's go back. And yes, you can look at the wattage for consumption. Yes, you can look at the score. But the overall value of what you get, you know, I've been a strong proponent of the TRX 40 and the CPU that we use in here. I think this is a great platform. But the water is getting a little bit muddy and a little bit murky for the TRX 40 in favor of the WRX80. And some other stuff we're going to be looking at is going to require, in my opinion, that because we need the resources for the PCI Express lanes. You see, here we're looking at processors. We talked about RAM, dual channel, And this is the quad channel I had reference to. Now, if you go with something like the AMD 16-core 5950, okay, because of the way the memory controller is configured on that, even though you've got 4 slots, you only want to use 2, because if you use all 4, you get a degradation in performance. Several of you have mentioned that, and it's one of those little things that I hadn't been mentioning. So we need to look at all those kind of issues. So with this, we've got 4 channels, but with this, all the facts are not there about apples and apples when you go to the WRX80, where you get 8 channels of memory, all functioning. And the fact that we can have 16 cores to get a low-end build. So you get the motherboard, you build a foundation, you got the chipset, and you're going to have, wow, 5, 6, 7. Now they're PCI Express 4.0, but 7 16-lane slots, or depending on the motherboard you choose, could be 6 16-lane slots, whatever. You get the resources to do things with, to add the stuff that you guys like to do. If you go this direction, you got 20 PCI Express lanes. 20 PCI Express lanes on PCI Express 5 gives you 1 slot, but it doesn't give you PCI Express 5 on 1 M.2 connector. You got a lot of shared resources that you can't do stuff with. And I've explained how bifurcation, how RAID, and all that plays out on that. It's, wow. Our goal is to keep things simple, make it work. I have a cousin said that it's kind of like building a Swiss watch with a Mickey Mouse face on it. Tell me what I got to do to make it work. And to make this work, to me, the Z690 is a square peg in a round hole. It looks good on paper, but from what I'm seeing on paper, from what I'm extrapolating, the Emperor's got no clothes. That's all I can say. One other thing I want to show you. I'll also include a link into AMD about the Threadripper Pro on the 3955 and looking at the specifications. 16 cores, 32 threads. It's PCI Express 4. It supports DDR4. Memory is 8 channels, DDR4 3200. So Shannon, I hope this helps to give you some more insight as I've shared my thoughts on what I think where things are. We're going to look at the technology. We need to examine it because there's going to be some more coming down the pike as this all plays out. But as it comes out of the gate right now, I don't think it's worth squat. So that's just my 2 cents. So my name's Gilboy. This is BuildOrBuy. I want to thank you guys for watching. We look forward to seeing you next video. We're out.